That hot cup of cocoa warms you up on a chilly day? Or how the sun beams its warmth all the way to Earth? It's all thanks to heat transfer, the amazing process of heat energy moving and grooving. We'll explore the three main ways heat does its thing: conduction, convection, and radiation. Get ready to become a heat transfer hero. We're talking about the science behind why you shouldn't leave a metal spoon in a pot of boiling water, and the reason why you can feel the heat of a roaring fire even from a distance. So, buckle up, science explorers, because we're about to unlock the mysteries of heat transfer together. Get ready for some seriously hot science. Ouch! That sudden jolt of pain when you touch something hot is a universal experience. But have you ever wondered what's really happening at a microscopic level when you touch a hot stove? First up, let's talk about conduction. Conduction is one of the primary ways heat travels from one object to another. It's a fascinating process that occurs right under our noses, or rather, right under our fingertips. Conduction is like a game of molecular tag. Imagine a bustling crowd where everyone is constantly bumping into each other. Each bump transfers a bit of energy from one person to the next. Now, imagine this crowd is made up of tiny molecules all huddled together, vibrating and bumping into each other. These molecules are in constant motion, even in solid objects. When you heat something up, those molecules go wild, vibrating even faster and bumping into their neighbors with more energy. This increased activity is what we perceive as heat. This energy gets passed along from one molecule to the next, spreading the heat throughout the material. It's like a chain reaction, where each molecule passes the baton of energy to its neighbor.
Think about what happens when you accidentally touch a hot stove. The heat from the stovetop is transferred directly to your skin through conduction. The heat from the stovetop makes the molecules in your skin vibrate faster. This rapid increase in molecular activity is what causes that sharp, painful sensation. Ouch! That's conduction in action. The direct transfer of heat from the hot stove to your poor, unsuspecting hand. It's a quick and efficient way for heat to move, but not so pleasant for us. That's why we use oven mitts, folks. Oven mitts are designed to protect our hands from the intense heat by providing a barrier that slows down the transfer of heat.
Metals are excellent conductors of heat, which is why we use them for pots and pans. They allow heat to spread quickly and evenly, making them ideal for cooking. But some materials, like wood or plastic, are terrible conductors, also known as insulators. Insulators are materials that resist the flow of heat, making them perfect for handling hot objects. They're like molecular slowpokes, not very good at passing along heat energy. This makes them ideal for use in kitchen utensils and protective gear. That's why you can stir a pot of soup with a wooden spoon without burning your hand. The wood acts as an insulator, preventing the heat from traveling up the spoon to your hand. Science to the rescue. So next time you're in the kitchen, remember the science behind why some tools are safe to use with hot food and others are not. It's all about the fascinating world of heat conduction and insulation. Understanding how heat conduction works can help us make better choices in our daily lives, from cooking to staying warm in the winter. It's a fundamental concept that affects us in more ways than we might realize. For example, the clothes we wear in cold weather are designed to trap heat and keep us warm. Insulated clothing works by slowing down the transfer of heat from our bodies to the cold air outside. Similarly, a thermos keeps your coffee hot by using insulating materials to prevent heat from escaping. It's all about controlling the flow of heat to maintain the desired temperature. So whether you're enjoying a hot cup of coffee or cooking a meal, the principles of heat conduction and insulation are at play. They help us manage and control heat in our everyday activities. Next time you're in the kitchen or bundling up for a cold day, take a moment to appreciate the science that makes it all possible. It's a reminder of how interconnected our world is, right down to the molecular level. And there you have it, a deeper look into the world of heat conduction and why touching a hot stove hurts so much. Stay curious and keep exploring the wonders of science in your everyday life. Next up, we have convection, the heat transfer party animal. Convection is one of the three main methods of heat transfer, alongside conduction and radiation. It's the life of the party when it comes to moving heat around in fluids, which include both liquids and gases. Convection is all about the movement of fluids, like liquids and gases. When these fluids are heated, they undergo a fascinating transformation that sets the stage for a dynamic dance of molecules. When a fluid gets heated, the molecules get all excited and spread out, making the fluid less dense. This excitement is due to the increase in kinetic energy, causing the molecules to move faster and occupy more space. This less dense fluid then rises while the cooler, denser fluid sinks to take its place. This process creates a cycle known as a convection current, which is essential for many natural and man-made processes. This creates a continuous cycle of rising and falling like a conga line of heat transfer. Imagine a never-ending dance where the participants are constantly moving up and down, transferring heat in the process. Think about a pot of boiling water. This is a perfect example of convection in action. The heat from the stove makes the water at the bottom hotter and less dense. As the water heats up, it becomes lighter and starts to rise towards the surface. This hot water rises while the cooler water at the top sinks to the bottom, gets heated, and rises again. This cycle continues, creating a uniform temperature throughout the pot. This constant circulation is what makes the water boil evenly. Without convection, the water at the bottom would get extremely hot while the top remained cool. It's like a dance party in your pot. The molecules are constantly moving, ensuring that the heat is evenly distributed. Convection is also what makes hot air balloons float. This principle is not just limited to liquids, it applies to gases as well. The burner heats the air inside the balloon, making it less dense than the surrounding air. As the air inside the balloon heats up, it expands and becomes lighter. This causes the balloon to rise, carrying you along for a breathtaking ride. The hot air inside the balloon creates a buoyant force that lifts the balloon off the ground. Just don't forget to bring snacks. Whether you're boiling water or floating in a hot air balloon, convection is the key to making it all happen. So next time you see a pot of boiling water or a hot air balloon, you'll know the science behind the magic. Convection currents are not just limited to your kitchen or the sky. They play a crucial role in weather patterns, ocean currents, and even the movement of tectonic plates. The same principles that make your soup boil evenly also drive the winds and ocean currents that shape our climate. In the atmosphere, warm air rises and cool air sinks, creating wind patterns that can affect weather systems. In the oceans, warm water from the equator moves towards the poles, while cold water from the poles moves towards the equator, creating ocean currents that regulate the Earth's temperature. Even the movement of tectonic plates is influenced by convection currents in the Earth's mantle. These currents cause the plates to move, leading to the formation of mountains, earthquakes, and volcanic eruptions. So the next time you enjoy a hot air balloon ride or a bowl of hot soup, remember that you're experiencing the wonders of convection. It's a fundamental process that shapes our world in more ways than we can imagine. And who knows, maybe understanding convection will make your next hot air balloon ride or cooking session even more enjoyable. After all, science is all around us, making everyday experiences extraordinary. Cheers to the amazing world of convection and the incredible ways it impacts our lives. Last but not least, we have radiation, the heat transfer superstar that doesn't need any matter to travel through. Unlike conduction and convection, which require physical contact or fluid movement, radiation can travel through the vacuum of space. This makes it a unique and fascinating form of heat transfer. Radiation is all about electromagnetic waves like the ones from the sun that warm our planet. These waves are part of the electromagnetic spectrum, which includes visible light, ultraviolet light, and infrared radiation. When the sun's rays reach Earth, they bring energy that heats up our atmosphere, land, and oceans, making life possible. These waves can travel through the vacuum of space, bringing us warmth even though there's no air between us and the sun. Talk about long-distance heat. It's incredible to think that the energy we feel on a sunny day has traveled millions of miles through the emptiness of space to reach us.
You can feel the effects of radiation every time you bask in the sun's glow or warm your hands by a cozy fire. The warmth you experience is due to the infrared radiation emitted by these heat sources. This type of radiation is invisible to the naked eye, but we can feel its effects as heat. The heat you feel isn't from direct contact or the movement of fluids. It's from the invisible infrared radiation emitted by the sun or the fire. This radiation travels through the air and is absorbed by your skin, making you feel warm and cozy. It's like magic, but it's science. The principles of radiation are used in many technologies we rely on every day, from microwave ovens to thermal imaging cameras. Understanding how radiation works helps us harness its power for various applications, making our lives more comfortable and efficient.
Different materials absorb and emit radiation differently. Dark-colored objects absorb more radiation, which is why they heat up faster in the sun than light-colored objects. That's why wearing a black shirt on a scorching summer day is a recipe for a sweaty situation. The dark fabric absorbs more of the sun's energy, converting it into heat and making you feel hotter. Stick to lighter colors, my friends. Light-colored clothing reflects more of the sun's rays, keeping you cooler and more comfortable on hot days. This simple choice can make a big difference in how you feel when you're out in the sun. So next time you're planning a day outdoors, remember to dress in light colors to stay cool and enjoy the sunshine without overheating. In addition to wearing light-colored clothing, it's also important to protect your skin from the sun's harmful ultraviolet rays. Use sunscreen, wear hats and sunglasses, and seek shade whenever possible. These precautions can help prevent sunburn and reduce the risk of skin cancer, allowing you to enjoy the sun safely. The power of the sun isn't just limited to warming our planet and our bodies. We can also harness solar energy to generate electricity. Solar panels convert sunlight into electrical energy, providing a clean and renewable source of power. This technology is becoming increasingly popular as we look for ways to reduce our reliance on fossil fuels and combat climate change. And let's not forget the role of sunlight in supporting life on Earth. Through the process of photosynthesis, plants convert sunlight into chemical energy, producing oxygen and food that sustain all living organisms. Without the sun, life as we know it wouldn't exist. So the next time you feel the warmth of the sun on your shoulders, take a moment to appreciate the incredible journey that energy has taken to reach you. From traveling through the vacuum of space to being absorbed by your skin, the sun's rays are a testament to the wonders of our universe. Embrace the sunshine, enjoy the warmth, and remember the science behind this everyday miracle. As the day comes to an end and the sun sets, the warmth fades, but the memories of a sunny day linger. The sun will rise again, bringing new opportunities to bask in its glow and enjoy the beauty of our world. Until then, cherish the moments of sunshine and the happiness it brings.